Welcome, my dear JEE 27 and 26 students. This is your Captain Shreyas. If you're scared about multiple pulleys, constraint motion, then this is the session that you should watch. So today in the live class, we are going to go to the final part of our Newton's laws of motion. We have already done friction, pseudo force, non-inertial frames, drawing FBD, tension, simple pulley problems, block questions, etc. So today we are going to do multiple pulleys and constraints, rod and wedge as well. Okay. So that will complete your Newton's laws of motion unit along with friction. So with me, your Captain Shreyas on the #1 J English channel for all of you in the country. Welcome aboard, everybody. And those of you who do not know me, well, you can call me Captain Shreyas, and I have been teaching for last 13 plus years. I did also my other software IT kind of job for 3 years. Before that, entering into teaching, I had always loved teaching and I love physics. I in fact got full marks in physics in my JEE advanced paper back then. So having done BTech from IIT Nagpur and research from IIT Bombay, here I am with you every single year, pushing you towards your final goal, which is your dream engineering college, whether it is an IIT, NIT, BITS, Triple IT, IISc. Well, this is the channel that you should be subscribed to. So if you have not yet done that, please do it and like the video in case you have not done it yet. Hi Bhanu, hi OnePlus. Wow. Welcome Albert. Hi Srinivasan. Pokemon is also here. Kavin Raja. Sir, I did purely in my maths test and coaching with some rank, and my friends are in the top, far better, achieving a lot. My parents compare me to them and I feel depressed. I mean, if your parents are comparing you after getting such nice ranks to All India rank 10, then first of all, stop listening. See, there are some parents are good, some parents are not bad, but it's just that they approach it in a very wrong way. They are thinking about your good only because they have gone through some struggles in their life. So maybe they are expressing it in a very different way by comparing. So ignore that comparison. Look at the positive aspect that maybe they actually are looking for good for you. Maybe they see something potential in you. Some people criticize, some people motivate. So often criticism doesn't work. Some parents do not get it. It's okay. So you look for motivation from within you if you can't seek it outside. You push yourself that I'm going to prove it to the world that I am, going to achieve this. Okay. So don't worry, my dear. And just probably have some positive friends. Maybe you can talk it out to your friends also. That way you will get to know that your friends also might be facing some or the other issue. Okay. So all the best. Yeah. Dilip. Yes, I do remember you. Hi, Bhanu. I do remember. Jack, I do remember you too. Hi, Azad. Good evening. Welcome aboard, everyone. Toji, Adarshana, Nitish, Harshida, welcome everybody to the live class. Good evening. Good evening. Welcome, Azad. Hi. Yeah. Thank you. I'm so glad. But my friends are the same. Oh my God. So if your friends are the same, then you have no other option. Sometimes, they say that miracles do happen. Sometimes you can have a friend who is not even preparing for IT but can be motivating. Okay. So I have seen many such students. They are maybe from commerce, art, some random stream, maybe an elder or a junior person also. If you find one positive person who can push you, just be with that person. Okay. That's okay. Right. So let's begin. And I hope you have registered for MVSAT. If you guys haven't registered yet, I mean, really, guys, what more? We need to push you, kick you, or what? Yeah, you're getting 100% plus scholarship. You're getting 150 crores worth of pool worth of that scholarship. 2 crores worth of prizes are there. You're getting a national level ranking. It's absolutely free of cost. Some institutes I know they charge some 100, 500 rupees and they earn through that. We don't do such things. Okay, we are giving our money to you in that scholarship. 4th October, 5th October, 11th and 12th of October. So enough time. If you select 11th standard, you will get 11th portion. If you select 12th standard, you will get 12th portion. If you select dropper, you will get both the things. Okay. So the portions depends on what grade you select. The link for joining the MVSAT is there in the description box of this particular video. Okay. So go down over here and you will see MVSAT register now. All the benefits, everything, the syllabus, FAQs, everything will come over here. And you will see the registration link over here. Looks like a lot of people are on to this site. That's why the site is loading slowly. But yeah, it will open up and definitely you can register. Okay. Cool, guys. All right. So let's begin with the class and let's start with pulley constraint. But first, let's understand what the hell is a constraint. Okay, what is the meaning of the word constraint? Constraint motion. Constraint means some kind of condition, condition, condition. Okay, some situation is there and some conditions are there. So constraint motion means conditional motion in such a way that that is the motion of the bodies depend on each other, depend on each other. If this moves by this much, then this moves by that much. That is what it is. So, example, if a body labeled A moves by some x, the body then the body B will move by some amount y, and x and y are some related variables. If this moves 5 meters, this will move 2 meters. If that moves 10 meters, this will move 4 meters. So some kind of relationship exists. That is why it is called constrained motion. Actually speaking, our simple question of a pulley with mass was also constrained motion. You need to identify, first of all, why is it related, dependable, or why is it conditional, and what is that condition. For example, over here, pay attention. There is a pulley, maybe there is a mass, and there is another mass here. If this mass goes down, this mass goes, yeah, a simple constraint like this. Imagine you have a pulley over here, okay, a string which is connected, and there is one mass over here, and there is another mass over here. So if by chance this mass comes down by some x amount, this mass will have to go by exactly that same amount, x only. Why? Because whatever amount you pull it by, that much amount of string will pass over the pulley, and that much amount of string will be demanded from this side. So it is related, conditional. If this happens, that happens. So it is a constrained motion. So because of which, if this mass has a magnitude of acceleration as a, then this mass also has a magnitude of acceleration as a. If this mass has a velocity of v, then this mass also has a velocity of v. So this is basically constrained motion. Everybody gets this? Okay. I will give it to you, Banu, don't worry. Yeah. In the format provided, yes, it is necessary to provide the caste certificate, Azad. Definitely you have to, or else you will not get the seat through that particular category. Okay, sir, now I understood. So if everything is XX, YY, then why do we need to study it? Sometimes what will happen, the pulley itself is movable and the mass is moving with respect to the pulley, and then things might change. Then you need to be little bit careful. Imagine the pulley itself is moving, this mass is moving, then this mass will not exactly move by the same amount. So you need to be little bit careful about it. Understood? So whenever you have movable pulleys, okay, multiple masses, multiple threads, that's when the situation becomes tricky. So how do we exactly solve such kind of questions? Let's see one by one. Say for example, let's take this particular scenario over here. Okay, let's take this particular scenario over here. Okay, see, in this particular situation, let's say this particular mass is moving by some amount x, this pulley is coming down with some amount. Okay, is there any relationship between them, assuming the string is fixed onto the other side? Assuming the string is fixed onto the other side. Okay, I think there is some relationship. What is the relationship? Let's visualize. It's pure visualization, supply versus demand. This pulley has come down by some amount x. Okay. If this particular pulley has come down by some amount X, let me show that one at the new place. See how it will look like. It will look something like this. Second, it will look something like this. Okay, it has moved by some amount over here. Okay, it has come down by some amount of XP. Okay, some amount of XP. All right, or you can just say X also, not an issue. If this pulley comes down by an amount of X, okay, if this pulley particularly comes down over here by some amount of X, what happens to this string here and this string over here? Both the sides, the string will now be slack, it will be loose, some extra string is there. This string which is wrapped is still wrapped on this pulley. It will just come down. Okay, so the string which was wrapped over the pulley, that has still come down, but this part of the string and this part of the string, what will happen to these both strings which are basically both X in amount? That string has now become loose. So you cannot keep the string loose over there. To make it tight, who can you pull? You can't pull this because this is fixed. So you will pull this mass down. You are just going to pull this particular mass down. Everybody agrees with this particular statement? Is it that any case to have different tensions in one string? We'll come to the different tensions also, Dilip. Hold on, one by one. So this mass will have to come down in order to tighten, because earlier the string was wrapped here. Now the string has to be wrapped here. So this much extra string has to be taken away. This much extra loose string has to be taken away. So what will this mass do, my dear students? Can you guys quickly guess and put it up in the chat box? This mass will have to come down by how much amount? By exactly 2x amount, because this x and this x both has to be taken down over here by this mass, so that the string, instead of being wrapped here, is now wrapped over this pulley. Understood? Earlier the string was going like this. Now the string has to go like this. So these two elements have to be taken down by this mass. So that is the relationship between the pulleys motion and the blocks motion. Yeah. So M will not just come by how much amount? 2x amount. So which also means if this pulley had some acceleration of A, can you guess the acceleration of the block? Can you guess the acceleration of the block? It will be exactly double. It will be 2 times of A. It will be exactly double, which is 2 times of A. Everybody got this visualization? Clear? Yeah? Everyone? Okay. So we understand now what is the relationship between their motion. Pure visualization, supply and demand. It is demanding, it is supplying. That's all. Let's go to this question also, and let's go to this question. Let's start with this one first. It's much easier. Okay. Start with this one. This pulley comes down by 2 meters. This mass goes up by 1 meter. How much will this mass move by? Wow, crazy constraint, right? This moves this much, that moves this much. So how much will this move if they are all related by some strings? That's what the question is. Okay. Whenever such question comes, do take into consideration each motion separately and then cumulatively add those effects to find the resultant motion. For now, forget this mass is moving. Just assume the pulley is coming down. Okay. Just assume that our pulley is coming down. Imagine if just the pulley came down by how many meters? 2 meters. If the pulley comes down by 2 meters, quickly tell me guys, there will be some string here and here also, 2 meters and 2 meters, which will become loose now. Loose extra string will be there. Agree or disagree? Everybody with me? So as soon as the pulley comes down, the string which was wrapped here will have to come here, but there is some extra string on both sides that needs to go down. So where will it go down? It will go to M1. So M1 will come down by exactly how many meters? 2 plus 2, which is 4 meters down. M1 will come down by 4 meters only because of the pulley. Only because of the pulley alone. Okay, sir. Now consider this guy. Who? This mass. Forget the pulley. Just consider this mass. If you just look at that mass is going up by how many meters? That mass is going up by 1 meter. That mass is going up by 1 meter. So forget the pulley is moving now. Assume only this mass is moving up. So string will go up by 1 meter. That string will go over the pulley. That string will go over the pulley of 1 meter. So this mass will further come down by how many meters? 1 meter. Everybody understands? Because this mass goes up, the pulley will allow that string to go over it, and this mass will further go down by 1 meter. So what is the total distance which that mass goes down by? 4 plus 1, which means 5 meters down. 5 meters down. That is how you need to visualize this. Is this absolutely clear? Okay. Okay. Sir, if we are at a scratch and complete a chapter quick, can we watch my road series to get a good grip? Yes, why not? Definitely. You can do that, Bhanu. Yeah. So it is not 3 meters, it is not 4 minus 1, it is 4 plus 1. You need to be very careful about the directions. Visualize it properly. If this goes up, this goes down, that goes down, this goes up, you need to see it. Okay. Let's try this question. Do not make any mistake now. I'm pretty sure you will be able to do this. Everyone, come on, let's try this out. Assume this pulley has come down by some amount. Okay, how much has it come down by? Let's see, it has come down by 1 meters per second square. So there is some string here and some string here which has now become loose. Loose and extra string is there. So if this is X, this is also X. The pulley has come down by some amount X. It is down by some X amount. It is down by some X amount. So 2X of string is free. So what will this mass do? This mass will definitely come down by 2X just because of the pulley alone. Forget this mass is moving. Just look at the pulley part. Okay, fair enough. So if the acceleration of the pulley was 1 meter per second square, if the acceleration of the pulley was 1 meter per second square, the acceleration of this block would be 2 meters per second square. Only because of the pulley. If this is X, this is 2X. If this is Y, this is 2Y. If this is 1, this is 2. If this is 3, this is 6. If this is 7, this is 14. Oh, perfect. Next thing, just look at this block. Forget the pulley is moving. This block goes up. Okay, this block, let's say, goes up by Y. So the string will be supplied by Y. So extra string which will go over the pulley, will be Y, and that same Y will bring this pulley down, this mass down by a Y amount. So if this is Y, it means that if this goes up at 1 meter per second square, this should come down by 1 meter per second square. So because of this mass. So the total acceleration, 2 down and 1 down, it will add. So it will be 3 meters per second square downwards. Is this now absolutely clear how we solved this? Everybody, just how to visualize I have taught you now. Yeah, these are constrained motions. If this moves this much, this moves how much? That moves this much, this moves how much? That is what constrained motion is. Okay, so we have got all the answers. 3 meters per second square, doubles, and this is basically 5, all of this. Okay, so 5 meters down, double, and 3 meters per second square. All these answers we have got it down. Okay, perfect. Now this is one type of constraint, but sometimes you can have multiple pulleys. As you can see in this particular questions, the pulley itself was moving. But what if the pulleys in themselves are multiple in nature? Then basically, I'll tell you what, just go by the method of tensions. It becomes very, very easy to solve the problem. Okay, so I'll tell you what is that method of tensions. Simple. If you take one single pulley, the string which connects the center and the string which is wrapped over the pulley, the tensions are related by simple Newton's laws. considering equilibrium, or better, I would say, net force on the pulley, should always be 0. Reason being, it's an ideal pulley. Ideal pulley means the mass is 0. So if the mass is 0, RHS is 0 in the Newton's second law. So if M into A, M is 0, MA is 0, so net force is also 0. So because of which, what will happen? The tension which is upwards will be balanced by the downward tension T1 and T2. But usually T1 and T2 are equal. So you can put T1, 2 T1, or you can also put 2 times of T2. So that is what this particular tension in the central string will be as compared to the string which is wrapped over it. Now imagine one more pulley over here. Then what is the relationship? It's again the same thing, guys. For this particular pulley, TP1 will be this T3 plus this T4, which is the same as 2 times of T3 or 2 times of T4, because the same string is connected here. So T4 and T3 are the same. Now this T4 becomes the central string for this pulley. So therefore, T4 will be equal to T1 plus T2, which is the same as saying 2 times T1 or 2 times T2, because the same string is connected. So T1 and T2 are the same. So it is 2 T1 or basically 2 times of T2. So if you keep on adding more pulleys, you can keep doing the same. And another simpler way of doing it is, see, if you assume this tension to be T, right? The same string is connected, so this will be also going to be, this is also going to be T. This tension will obviously be double the tension, T and T down. This central string will have 2T. This same string is connected here, so this will be 2T. This is 2T, this is 2T. This will be how much? This will be 4T. So this is very easy to build upon rather than going by variables T1, T2, T3, T4. Everybody clear? Everybody clear? Yeah. Teamwork, you can definitely meet me personally. Register for MVSAT. If you register, yeah, from the links here, then I will get to know you are interested to meet me. Then I'll come to the center. Hyderabad, Coimbatore, Trichy, Pune, Bangalore, wherever you are. So make sure you're registering, because I also have 4 dates. So 4 cities I will be able to travel maximum. So, please make sure you're registering for MVSAT. Yeah, the links are there in the description. Sir, is smaller mass got acceleration when pulley moves down? I didn't get you. Really. Teamwork, thank you for all the love from Tamil Nadu. I got all India rank 4786 in JEE Advanced 2025 because of my teaching. I'm so happy. Wow, yaar. 4786. What a rank, man. Kudos, teamwork. And really happy for you. I'm pretty sure you will be entering some IIT this year only. And probably you are going to get a decent branch as well. Really proud of you, my dear. And you are making Tamil Nadu students this channel and your juniors very proud of you. And they will be looking up to you, and more students from Tamil Nadu and many other southern states will also, look up to you. Very good. Keep it up. Thank you so much for coming over here and mentioning it. It's going to be very motivating for the kids. Okay. Now, if you do the same thing for even more pulleys, same thing logic, guys. If this is tension T, the same string is going here, same tension. The middle string which is there, the middle string, it will balance these two tensions. So this will be basically 2T string, 2T tension. The same string will go here. So this will be 2T. Now, these two 2Ts at the center will make 4T. The same string is going here. So this will be 4T. And the central string over here, 4T plus 4T, it will be basically 8 times of T. It will be basically 8 times of T. Everybody gets it till this point? Everybody gets it till this point? How the tensions get, carried forward? How every time it is getting doubled. The moment you connect it to a much big, a pulley which is connected at the center, the tension is doubling. Again, a pulley connected to the center, tension is doubling. That is what is happening in such kind of questions. Okay. Now, even if the string is at an angle, don't get worried. The tension will still be the same. If this particular tension is T, the tension is T over here. The tension is basically T over here. Okay, it's the same tension because same string is there. Also, if this block moves up by some x, because the string is being pulled in this direction, the same string will move over the pulley and it will be supplied here. So this will also move by x. That means if this guy has an acceleration of a, the acceleration of this particular point will also be a only. Will also be a only. Again, this is simple constraint motion. Now comes the challenge when you have a movable pulley over here like this or something like this over here. Yeah, all these are constrained motions. All these are constrained motion problems. Multiple pulleys are there. Sir, how to solve these kind of questions? So now I'm going to give you a big trick over here. Observe this carefully. Okay, observe this carefully now, my dear students. The trick, whatever I'm going to give you. Okay, whenever you have multiple blocks, pulleys, and you want to figure out the constraint motion, how it is working, then first learn this art of marking tensions, T, 2T, 3T, 4T, 8T, whatever it is. You should know how the tensions carry forward, like over here or even over here. Like if this is T, this is T, this will be 2 times of T. Yeah, this basic art you should know. Number one. If you are scared of such visualizations, if you cannot visualize every single time, then there is a trick which works in certain situations, which I'm going to show you. What is that trick? The trick is basically the acceleration of a block, or basically, if not acceleration, the motion of the block, is going to be inversely proportional to the tension along the motion, pulling the block, tension along net tension along the motion pulling the particular block. That's it. This is the trick which you have to use for solving the questions. Easily you will be able to get the answer within a single step. Okay? How? Let me show you. How exactly? Let me show it to you. Forget about this problem. First, let's do some application questions. Then I will come to these questions. Hold on 1 second. Imagine a situation where there is a block here, okay, and another block over here, maybe another block over here, maybe, and there is, let's say, a pulley connected over here like this, and yes, there is string connected here, and this is connected to the roof. This is going here, maybe this is going here like this, and yes, there is a pulley over here, and it is connected like this onto this particular surface. Okay, like this. Amazing. Now, this is a multiple pulley problem, multiple block problem. Okay, and the question says whenever you have such things, you can use this property. Okay, and let's see how exactly does it work. Say, for example, I call this block number 1, I call this block number 2. How do we exactly apply it over here? First thing, mark the tensions. Basic thing, mark the tensions. If on this block, the tension is T, the same tension will go over here. There will be a tension of T over here and tension of T also over here. Then on this string, the tension which will be there, which will pull this block, will be obviously 2T. That is the first thing that you need to do. This much part clear, which we have already done. How to solve multiple pulleys, I just told you over here. Okay, tension, how it works from one pulley to the other. Okay, once that is done, let's use this property. What does it say? the motion or the acceleration of that block is inversely proportional to the net tension along the motion. Okay, which means the tension right now is along the motion. Yes, this 2t is also along the motion. This tension is inversely related to the acceleration or the motion. So block 1 has tension T, block 2 has tension 2T. Block 1 versus block 2, if you ask me, block 1 has tension of T, this has a tension of 2T. So if they are inversely related to the acceleration, if this has some acceleration, this also has some acceleration, then that means this should have an acceleration of A, this should have 2A, inversely related. So if this goes down by X, this goes here by 2X, or this goes by 2A, and this goes by A. So easy. Directly you can do it. Directly you can do it. Isn't it simple, guys? Hi Aditya, welcome aboard. Sir, is it any case to have different tensions is the same as the case of different tensions only come when the pulley has mass. Right now we are studying ideal pulleys, so we are not worried about pulleys with mass which comes in rotational motion. So that's why TT will become 2T, else T1 plus T2 will become T, which will be in rotational motion where the pulley itself has some moment of inertia, etc. Not as of now. Okay, Dilip. Hi, Sekhar Babu, welcome. Yep. Everybody got it till this point? Very easy trick. Okay, let's apply this trick and see what happens exactly then. Let's apply this trick. Okay, this was not needed here. Let's apply this trick over here. Okay, see this particular question. This person is pulling, this block is moving up. Apply the same trick and see if you can get the same answer. Okay, so you are pulling this particular end of the string with some tension T. The same tension is going here, and the tension will go around this also. It will be T and T on both sides. This pulley is connected to this block, so this block will experience a tension of 2T. Okay. Now, like I said, tension should be along the motion or take the component along the motion, which it is already. This is moving like this is moving like this. So tensions are already along the motion. So if this is T, this is 2T, that means this will move by 2x and this will go up by x. That's it. Or if this accelerates by A, then this point here will be accelerating double of that. So 2x, x or 2A and A. That is the answer, which is exactly it is. X by 2, okay, or one and the same thing. Everybody with me? Understood? Clearo? Very simple, very easy to do this now. Very, very easy. All you have to do is look at the tensions and just do the inverse relationship. Okay? Let's go to the next one coming up on your screen. Let's see if you can do it. Okay, this particular question, my dear students. This particular question, my dear students. Let's do this. Let's start marking the tension first. I'm pulling it. So maybe there is some tension pull, which is T. This string, look at the string carefully. So there will be a tension of T here. The same string will go over here. So that will also have tension of T. This will go here. Oh, crazy. This will go here. And again, it will come here. So this is also going to be T. And this will be 2T. But don't worry, it is fixed somewhere. So forget that. It is fixed somewhere. So forget that. Now, this T, T and T together on this pulley will give a tension of how much in this string? 3 times of T. Do you get it? Why 3T? T, T, T up will be balanced by 3T down on the pulley. So on the block, the tension will be 3T up. So this element will be balancing these 3 tensions together. Now the diagram is complete. Everybody gets this? Now, like I said, check the tensions along the motion. Yes, it is inverse relationship. T, 3T, accelerations, motions will be inversely related. So this will accelerate by A and this will accelerate by 3 times of A. That's it, done and dusted. Got it, my dear warriors? So easy it is, my trick. You don't have to break your head only after this. Welcome. Boila, you are going to have a big surprise which is coming very soon on the channel. Okay? Clear till this point? Everybody understood? Okay. Yes, sir, I understood it. Sir, give more problems now. This is so much fun. I thought multiple pulley problems means it is very, very difficult. No, bro, it is very laddu type only. Let's do one more question. Okay, coming up on your screen. Imagine there is a rod like this, and then there is a block over here which can slide, and you are taking one more block over here, and there is a pulley like so, and the string is connected over here, and it is connected over here, okay, like this, and this is attached to the roof. This is some rod over here. Now, on this rod, this block can only go up and down. Right now, it is making some particular angle theta, and the string is hanging a block over here. So if this moves down, this goes up. If this is pulled down, this goes up. So how are the motions related to each other? Start with the same logic, tensions first. Okay, if there is a tension T over here, the same tension will go here and it will be like this. But always check the motion. See, if this person goes down or up like this thing should go up or down like this. The tension is not along the motion, so I have to split the component. So think carefully. If this is the tension, how much will this component be? This will be T cos theta. This will be T cos of theta. Everybody agrees? Always check the tension along the motion. So you should know where it is actually moving. It is constrained to move along the rod. So if this is T and T cos theta, it's quite obvious exactly opposite should be the accelerations or motion. So if this is A, this will be A cos of theta. And if this is having some motion of velocity V, then this velocity will be V cos of theta. Again, if this is going up by X, then this will go down by X cos of theta. That's it. So easy peasy, lemon squeezy. So Chitra, like I explained over here before, the relation is acceleration of the blocks is always inversely proportional to the net tension along the motion. Before this, I gave you how we show the tensions, how we figure out the tensions of multiple pulleys by simple logic. Wherever the pulleys are there at the center, that string will have double the tension. Again, it is connected somewhere, double the tension. That is the simple logic. Now, once you understand that, you are given any situation, mark the tensions. If the tensions are T and 2T, T and 3T, accelerations are exactly opposite, 2A and A. If this was T and 5T, this will be 5A and A. That's all. So the same thing I have applied over here also. Where is it? In this situation, there is only one string connecting this. So there is one tension here and the same tension is here. But this block can only go up and down. Yeah, if this goes down, the string pulls it, so it will go up. So it will go like this. It will go like this. But the string is always making some angle over here. So there is some angular relationship also. So that is why I first split the tension into components, but only worry about that component along the motion, which is T cos. So T cos theta versus tension, this will be A and this will be A cos theta. Exact inverse relationship. Got it now, Chitra, Jnani, Adarsh, Dilip, everybody onto this. You cannot make any mistake after this. All right. Sir, give us more questions. Don't worry, bro. More questions are coming. Imagine this situation. Imagine this particular situation where you have been given a rod like this and there are two blocks. Both the blocks are constrained to move on that particular block only, on that rod only. And something like this, let's say this block, the string goes like this, it's wrapped over that pulley, it is connected over here. Okay, this is like a pivot. Okay, so this block can move here, this block can also move left and right, and this pulley is attached over here. Question is, find out the relationship between them, assuming this is theta 1 and assuming this is theta 2. Okay, or you can take it alpha beta also, nothing wrong with that. All right, let's start. First of all, let's see the tension. Yes, there will be one tension in the string like this. So the tension will be T. The same string is continuing. So that same tension will be over here also. So same tension will be there here also. Okay. So same tension is there, same string is there. But is it along the motion? I doubt. Why? Because if this block moves like this, then see the string will go here. It will pull that string, and because the string is being pulled, this block will have to come closer. So this block will have to move like this. So the tension is not along the motion. So find that component along the motion. How much is this component going to be? T cos theta 1. How much is this component going to be along the direction of the motion? T cos theta 2. That's it. So that's it, guys. The if this is, let's say, x, if let's say this is y, then remember x by y is inversely related to the tension, meaning x will be related to this tension inversely. So this will be t cos theta 1 and y will be related to t cos theta 2. T will cancel. So we can directly then get x into cos theta 1 is y into cos theta 2. That's it. That is the relationship between x and y. That is the relationship between x and y. So if you want y versus x, so you can say y is equal to x into cos theta 1 by cos theta 2. You know the angles. If you know how much x is, you can find how much y is. Understanding how to solve this question? Yeah. Nani, Chitra, Bolivia, Adarsh, Dilip, everyone, Aditya, Gomati, teamwork, everybody, Banu, Azad, Jack, Pokemon, Srinivasan. Yes, 1 plus. Let me know quickly in the chat box. Sir, if straight line block is moving with acceleration means, then also same thing. Then also same thing. Straight line it is moving. Then what? Then also angle you should know. That's all. And tension you should know. Okay? And they should be somehow related with the tensions. If they are related with the tensions, your job is done. Okay. Sir, but there could be some question where 3 blocks are there. Yes, 3 block question can also come. Sir, what kind of question can be a 3 block question? Observe this. One platform is there. Okay, like this. And then let's say one pulley over here. And this is going here like this. This is going here like this. This is connected over here. And then there is one pulley over here. One pulley over here. Then this is going like this. This is going like this. Okay, multiple pulleys. Then you have a block here and another block over here. This kind of question can also come. Okay, how do we solve that question? What is the relationship between their accelerations? Okay, what is the relationship between their acceleration? If friction acts along the block but not the other. Very good question, Chitra. Sir, what if friction is there? Sir, what if masses are there, etc.? Okay, tell me one thing. Let's say the pulley has a mass. Let's say the block has a friction. Let's say the string has some mass. Non-ideal situation also. Does that mean that now the acceleration relationship will be different? I don't think so. Even if there is friction, yes, the block will go slowly. But if this moves down, this has to go right by 2 times. There is no compromise on that. It is non negotiable. Yeah, If earlier the acceleration without friction, without mass of the pulley, etc., was maybe 7 meters per second square, now it might come down to 3 meters per second square. But if this was 7, this will be 14. If this is 3, this will be 6. The relationship will not change, because the relationship is not because of friction, not because of the mass of the pulley or the string, but rather geometrical relationship. It is the geometry of the situation. And the geometry has got nothing to do with friction, non-ideal of the pulley or string mass, nothing. What is the mass of this guy and this guy? I don't care. Nobody knows, and nobody should care also. So even if this is heavy, this is light, this is heavy, this is light, string has mass, pulley has mass, string has friction, pulley has friction, this has friction, still this goes down, this is compelled to go double the times. Same thing over here. Here also, same thing over here also, right? If this goes A, this has to go 3A, even if the pulley has mass or even friction. Because this is a geometrical constraint. It has nothing to do whether what is the mass, whether it is 7 kg, this is 2 kg, what is the person's weight, whether he has friction, nothing to do. Got it? Understood? Sir, in the previous question, if the straight block is moving with the acceleration, then also you can do it, my dear. Then also, if this is y and x, this will be acceleration of this guy, this will be acceleration of that guy, a1 and a2, just same relationship. Okay, same relationship. Yeah, okay, perfect. You just take the derivative of it, but it is at that instant, because actually what happens is, as they move, theta will keep changing, so theta needs to be differentiated. So that is why for acceleration and velocity, you need to be little bit careful that we are talking about at that moment. It's not an average value, number one. Number two, it is assuming theta has not changed much during that motion. So usually it is assumed that the relationship will be valid when it has just started from rest, not while it is already in motion and it has some 70-50 meters per second. So if it already has speed, even in the dt time, the theta will change so much that you cannot assume theta as constant in that part of the motion. So only when theta is roughly the same, then only you can take acceleration of this versus this is going to follow this relationship. So if I call this number 2 and this is number 1, so if you differentiate it 2 times, the derivative of y 2 times will be acceleration of 2, derivative of x 2 times will be acceleration of 1, and this will be nothing but cos theta 1 by cos theta 2. This is initial when it just starts, not otherwise, because otherwise it will have good velocity and theta will not be constant. Okay, even in before, same thing, even in before also, if it all, oh, this block has horizontal motion, you are saying, then it's just that theta will be at that moment, given to you. So maybe the problem will be something like this. So if this theta is given to you, again take the tension and the angle made by it. Okay, and the angle made by it to find the component. Okay, that's all. Perfect. Now in this question, what you need to do? Now you cannot use the tension method over here because T is there and there are 3 blocks. Be careful, there are 3 motions, so you cannot use my method now. You will have to go by visualization. How do you go by visualization? Let's see, guys. Let's take this as block number 1. Let's take this as block number 2. Let's take this as block number 3. In such situations, what you do is move one of the block, keep one block fixed and see the effect on the other one. Say for example, in this case, I do not move this. In the next case, I do not move this. Okay. So if this doesn't move, so it's as if saying there is a fixed wall over here connected to this string. Nothing will happen here. In this situation, if this doesn't move, there is a fixed wall over here and it doesn't allow the string to move. Okay. Fair enough. Now imagine this block over here and this block over here, they begin to move. Say for example, this block number 3 comes down. If block number 3 comes down, what will happen? pulley will also have to come down by the same amount. Okay, the pulley will also come down by the same amount. Okay, so the pulley has come down like this. So how much did the pulley come down by? Well, just check how much did the block come down by. It came down by x. So pulley also comes down by x. Pulley also comes down by x. But wait a minute, where is that string? Because earlier the string was wrapped like this. Now the string has to be wrapped like this. So from this to this, how much extra string we need? We need a string here and we need a string here also. Both these places we need a string. So x and x, how much extra? Extra 2x string is needed. Extra 2x string is basically needed. Where will you get these strings from? You can't get it from here because this is not allowed to move. So you can only get it from this guy. So that 2x will have to pass over the pulley. That means this block will definitely have to move over here and by an amount of how much? 2x. Is this absolutely clear, everybody? The logic behind it? Yeah. Now imagine the second scenario. Now imagine the second scenario. This is fixed. This is allowed to move. Same logic you use, guys. Same logic you use. Again, this 3, assume it comes down, but by different amount because you are moving a different block. Why? So obviously, this pulley will come down by some amount like this. And this string is connected over here. So this pulley will also come down by the same amount. Why? But the string was wrapped here. Now it has to be wrapped around this. So you can see some missing part over here and missing part over here. So again, extra amount of 2y string is needed. Extra amount of y plus y, which is 2y string is needed. Where will it come from? It can't come from here. So it has to go over this pulley by an amount of 2y. That means this particular block will have to go this side by how much amount? By an amount of 2y. Is this absolutely clear? So this will go by 2y. Now the final stage is where you combine both of them. So you think like this. If this block goes by x, if this block goes by x amount, then this block goes by double the amount. This block basically goes by double the amount, 2x. Similarly, if this block further goes down by y amount, this block goes by how much amount? 2y amount. 2y amount. Okay, so I can alternatively say that if by chance this goes by some y dash amount, this is going down by how much? Y dash by 2. And if this goes by some x dash amount, this is going down by x dash by 2. So if this moves by y dash, this moves by x dash, this goes down by x by 2 dash and y by 2 dash. So it kind of means that the net motion of this block, the net motion of this particular block is x dash plus y dash by 2. Oh, so it means what? If this has an acceleration, of a1 and this has an acceleration of a2, then this block over here will have an acceleration of this plus this by 2. That means a1 plus a2 divided by 2. That is what it means. Got it? Everybody, how to solve this question? I'll repeat quickly again. In this situation, this block comes down, both these blocks will also move together, but their accelerations could be different. So what we did is, first we fixed this guy, and then we saw if this block comes down by some amount, how much effect will it have on this? Vice versa, if this moves this much, how much effect will it have on this? Then you fix this, see how much will these two affect each other. Now combine, superimpose both their effects. So if this moves and this moves, how much will this move by? So if this moves by x prime, this moves by y prime, this will move by x prime by 2 and y prime by 2, both down. So if this has a acceleration, this has a2 acceleration, then this will go down by a1 by 2 plus a2 by 2 acceleration. Got it now, everybody? How to solve these kind of questions? Everyone with me? Multiple pulley problems? Done, dusted, perfecto. Okay, let's see if you can solve this particular question. Okay, there is an inclined plane, all surfaces are smooth, the strings are light, the acceleration of the block of mass 2 kg is, this was asked in JEE 2024. Okay, let's start by drawing the FBD first. Okay, let's draw the free body diagram first. Okay, as you can see, there will be one tension over here. That same tension will continue over here and over here. So if you ask me this particular block, it will have a tension of 2T. Yeah, we just saw that first. Is that clear, everyone? Hi Pritija, welcome aboard. Little bit late, I guess. Same string continuing. So T, T, T. So therefore, this will be 2T. This was T, this was T. So this will be 2T. Okay. Next, I'm showing FBD of the block. Okay. No point drawing FBD of pulley now. This 4 kg weight will be down. So 4G will be down. This weight will also be down, but it will have two components. One component like this and the other component like this. This will be 4G cos 30. This will be 4G sin 30 component. This will be 4G cos 30 component. And of course, one normal will be there. Smoothness is there, so no friction. Last thing that we need to show is the acceleration. What logic did I tell you? If the tension has to be seen along the motion, it is inversely related to the acceleration. If the tension is already along the motion, T and 2T, if this is T, this is 2T, the acceleration, what will it be, guys? Yes, this will be basically 2A and this will be basically A. Everybody with me on this? T, 2T, so this will be 2A and this will be A. That's all. So once the FBD is properly drawn, now we can solve it. For the 4 kg block, what will be my equation? Let's write it first and then we will worry about the 2 kg block. Okay. For the 4 kg block, as you can see, 4G force is downwards. The 2T tension is upwards. This is the net force, is mass, which is 4 multiplied by A. Okay, sir, this is done. What about this? Okay, along the acceleration, tension will be positive, 4G will be negative. So for 2G, tension minus 4G sine 30 is the net force, is equal to mass, which is 2 multiplied by acceleration. Acceleration itself is 2A. Do not forget that. A lot of people make a mistake. They write A. No, it is different. Tensions are also different. Okay. Now what do we do? I think it's best we solve this now. Tension minus sine 30 is half. So 4 into half is 2. So 2G is equal to 4A. I look at this equation and I get the idea, if I multiply this with 2, I can add them and subtract to cancel tension. So if I multiply by 2, this will become 4G. This will basically become 8A. Now just take this particular equation and this particular equation, okay, and add both of them and just add both of them. 2T and 2T gets cancelled. That thinking you should have, or else you will miss out on that manipulation. So you will get 4G minus 2T plus 2T cancelled, minus 4G over here also. Wow, 4G here and here also 4G only I am getting, pakka. This is 30 degrees. Okay, fair enough. All right. Okay, and this is how much I am getting, 4A plus, did we miss out on something? Just check it out, or the acceleration will be basically 0 then. This will be basically 4A. This will be basically 4A plus 8A. That is nothing but 12A. So this is 0. So acceleration will be 0. That means by chance, this is just going to be at rest. By chance, this is just going to be at rest. Yes. Sir, it's 2G, 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 2G. Oh, ho, ho. Yes, we made a mistake. I'm so sorry. Yes, thank you so much for pointing it out. Sorry, guys. I'll just redo this. This was not 4G, this was 2G. Here also and here also. So sorry. So this was basically 2 kg. So this was 2G cos 30 and this was 2G sin 30. Sin 30. Anyway, 0 was not there in the option. Yep. Now is it fine, guys? So if you ask me 2 kg blocks equation, tension is in the direction of acceleration minus this force, which is 2G sine 30, will be its mass, which is 2, multiplied by the acceleration, which is 2a. Now, if you solve this, t minus sine 30 is half, so 2 into half is 1. So minus g is equal to 4a. Look at this and this, you can multiply it with 2. So 2t minus 2g is equal to 8a. Why did we do it? So that 2t and 2t will cancel off. That's all. So let's write it down over here by adding both the equations. What do we get? We take this equation and we take this equation and we add them both. So what do we exactly get? We have 4g over here, 2t and 2t cancelled, minus 2g is equal to 4a plus 8a. 4a plus 8a. 4g minus 2g is 2g is equal to 4 plus 8 is 12. So 12a. So g is equal to 6a. Therefore, a is equal to g by 6. A is equal to g by 6. Now, lot of people will look, sir, no option is there. But read the question. The acceleration of 2 kg block. So what is the acceleration of 2 kg? Acceleration of 2 kg block, that is 2a. So it will be 2g by 6, which is technically g by 3. So g by 3 means option D. Option D will be the right answer. Understood, my dear warriors? Perfecto. I'm so glad that you are doing so well, Abhiram. So good. So good. And continue that same spirit. Right now, you're in 12th, I believe. So, all the best for your boards and continue watching the classes. All right. Perfect. Perfect, my dear warriors. Now, let's see if you can figure out the relation between the accelerations in this situation. Okay. Beautiful question is there. Okay. The arrangement shown is ideal. The respective accelerations of block A and B relate. What is the relationship between them? Okay. Start drawing the tensions. That's all. Start drawing the tensions. Okay. If this string is considered, the string goes like this. This tension will be here. This tension will be obviously here. The same string is going here. So the same tension will also be here. Oh, but that creates a problem, isn't it? That creates a problem. Why? How can this be tension? How can this be tension, guys? Think about it. Because if this is tension, then how can it be equal to 2t then? How can it be equal to 2t? Because this central string should have exactly double the tension of these people. That becomes an indeterminate problem now. Getting my point? This becomes an very indeterminate problem. Okay. Monkey problem. Which monkey problem you want, Sudarshan? So we can't use tension in this. Yeah, we can't use tension because if you use tension, then you will be stuck. Sir, what is this happening? Sir, same tension is going like that. Okay, so you will be stuck over there. So the only possibility is by visualization now. So forget this thing over here. Just forget this thing over here. Just imagine, let's say this particular block which is there has gone down. Okay, just imagine this particular block has gone down by some amount. Okay, chumma like this. So let's say it has gone down by some amount of x over here. So as a result of that, this pulley will be affected, and this pulley 100% will also come down over here like this. Will also come down over here like this. So it would have also come down by an amount of X only. Okay, everybody with me? Everybody with me? Now it needs some string over here and some string over here. So it needs a total length of 2x string. It needs a total of 2x string. Now the problem is, where will it ask from? Because it can ask from here also, it can ask from here also. Okay, and what will happen to this pulley then? Because if you consider this particular pulley to be movable, then it becomes a problem. Then it becomes a problem. Why? Because if this moves, then this string also will move, and this block is also moving, and T can't add to give 2T. So the only possible way is if this particular pulley was exactly fixed. Only this pulley was fixed. Okay, so I think that information is missing over here. So this particular pulley is fixed, and only then this entire thing can happen. So if this particular pulley is fixed, this string can't be supplied from here. This string can't be supplied from here. Think about it. Because you need that 2x string. If you ask this guy, it will ask this guy, how will the string come out from here? So it can't. So that means that 2x string has to come out from here. So that means this mass is going up by 2x amount. This mass is going up by 2x amount because you need 2x string. You need 2x string and it can't be given from here. So hence the final answer will be this B block. If it goes with acceleration A, this M1 block will go up by an acceleration of 2A. That's the relationship between them. Okay. I don't think the both blocks will be B. It will be A and B. I think it's a misprint. Don't worry about it. And also what we saw is this pulley can't be movable. This is very, very important. Okay, this pulley, if you notice, this is very, very important, guys. See, if there is a tension T here, there is a tension T here, how can this be also equal to T? It is impossible. It is impossible. So, therefore, we said that the only possible explanation for that is you fix this particular pulley. You fix this particular pulley. So, there will be some kind of a normal reaction wherever it is fixed. And yes, that tension will be there from the top, that same string which is connected. Now it kind of makes sense that T plus N will be T plus T down. So T plus the normal will be T plus T down. So the normal force will be the tension. This normal, where is it coming from? Wherever it is fixed. Wherever it is fixed, that is what that support is providing that normal. Okay, absolutely clear. Pritija, what was your doubt? I'm not really sure. Today my school bus started too late. Sir, I'm not really sure. What was your doubt? I didn't see your doubt. Yeah. Okay, cool guys. Perfect. Amazing. Now let's go to the final type of problems, which are rod constraints and wedge constraints. Rod constraints and wedge constraints. Okay, what is rod constraint? There is a rod and it is moving and you have to find out the end's velocity. That's all. That's the kind of questions you will get. And the concept used here is very laddu. If you have a rod, doesn't matter in what direction, then every single point on the rod, no matter where you take it, no matter where you take it, okay, doesn't matter, will have the same velocity along the rod. Meaning, if for example, this is velocity v1, this is velocity v2, and let's say it is making some angle beta over here, and let's say this is making some angle alpha over here. You take the component of velocity along the rod, which will be v1 cos alpha. You take the component along the rod, along, not perpendicular. This will be v2 cos beta. So all the velocities, all points have same component of velocity along the rod. And the reason for that since the length of the rod is constant, if the length of the rod is constant, just think about it. Just think about it. If this is a rod and this point has some velocity, let's say u, this point also should have same speed u. If they have different speeds, then the rod length is changing. That is the reason why the speeds along the rod should be the same. Perpendicular, they could be anything. It will just cause rotation. That's okay. If there is a component like this or like this, it will just rotate the rod. But these components, what are they doing? They're just shifting the rod. But if one is more, one is less, then the rod is compressing or elongating, which can't happen. The rod is a rigid body. So that is the reason why this will be true. So even if you take a point somewhere here, that will also have the same velocity. All the points have the same velocity and direction. Okay. Is this absolutely clear? Okay. Thank you, Sai. Oh, came to see me or Abhijit? Are you? Hello, Alekia, Vansh, welcome. Oh my God, please don't tell me you came to see each other. I will feel embarrassed now. Okay. So, what kind of question can come? This is one of the most famous questions which you have in rod constraints, where you have a surface like this, and you have a rod here. And the rod is making right now some angle, maybe theta. And question is, this point has some velocity. This point has some velocity. Find the relationship between these velocities. As the rod will slide down, it will slide down. Find the relationship between the velocities. That kind of question. So let's start. This point on the ground will start moving this way. Let's say the velocity is v1. This point on the top vertical wall will start sliding down like this as they keep maintaining the contact. So this will be v2. Okay, fair enough. Now let me just show the extended version here like this. So if this is theta, obviously this is going to be theta. If this is theta, this is 90 minus theta. Okay, so maybe I should, yeah, this will be nothing but 90 minus theta. Is that right? This particular angle over here. Okay. Now just take the components of the velocities along the rod. This component along the rod like this. How much will it be? V1 cos theta. Take this velocities component along the rod. It will be V2 cos 90 minus theta. As per the theory, both the components should be the same. So V2 cos 90 minus theta should be V1 sin, V1 cos theta. Now, V1 cos theta is as it is, but what about over here? Cos 90 minus theta is sin theta. So, basically shift cos theta over here. So, sin theta divided by cos theta will be equal to V1 is there as it is, V2 comes down. So, therefore, V1 by V2 is nothing but tan theta. So, we got the relationship. V1 by V2 is tan theta. Like, sir, this I could have done it geometry only, no? Like, yeah, okay, what, sir? I will do. See, you can just say tan theta is opposite by adjacent. If you do that, you will get V2 by V1, not V1 by V2. So be very careful. Lot of students do this mistake and they say, sir, tan theta is opposite side by adjacent side, so it is V2 by V1. First of all, tell me, V2 is velocity. How is this length V2? How is this length V1? These are geometrical heights and widths. So they are not V2 and V1. The velocity is a vector along this length and along this length. So do not write this. Tan theta is not V2 by V1. It's opposite side by adjacent side. Side is not equal to velocity. Got it? I'm very good, everyone. Yes, welcome aboard. In physics, we say displacement can be zero when the initial and final position is same. But in maths, why triangle cannot be called as a displacement? Meaning? Triangle can't be called as displacement as in, I didn't get your point, Pritija. What do you mean by that? Triangle can't be called as displacement as in? Yeah. Sai, you can continue watching the classes over here only. I won't be taking any live class at least for the foreseeable future in the NEET English channel for teaching purpose, because anyways the students were watching here only, so might as well continue watching here only. Yeah, so watch the JEE classes for NEET, it's fine. Okay, maybe you can skip some complex questions, but anyways the physics these days is difficult, so you can watch except for the advanced classes. Okay, all right. So all I said, Sudarshan, was you cannot say tan theta is opposite side by adjacent side. Sorry, you can say that opposite side by adjacent side, but the side is not equal to velocity. Velocity is a vector. How much is the length? I don't know. It could be this, how much ever it is possible. Just because this side and this side are parallel to V2 and V1, you cannot say this. Getting my point? So, yes, tan theta is opposite by adjacent, but it is definitely not equal to opposite, which is V2, which is V1. No, because speeds and displacements are totally different in this situation. Okay, it's just parallel. Okay, perfecto, understood, clear. That is what your, where did it go? Rod constraint is. That is what your rod constraint is at the end of the day. Now there is another kind of constraint which is called wedge constraint. We'll understand that. What is this wedge constraint? Wedge constraint means you will have something like this situation. Imagine like this, and then imagine something like this is given to you. This is called as wedge constraint. These kind of questions where that yellow block is constrained to go up and down only, constrained to go up and down, or like this at an angle, something like this over here. And this orange block can slide on the horizontal surface like this. That is basically your wedge constraint. That is basically your wedge constraint. If you push this down, this block will slide here. If you push this down, this block will slide here. So wedge related constraint. What to do in such situation? What to do in such situation? Okay, think, my dear students. Class more for 5-10 minutes, that's all. In such situation, the idea is always choose the point of contact between the two objects, whether the wedge, block, whatever. Choose the contact surface, and whatever the velocities actually are, maybe this yellow block is actually moving maybe at some angle like this. Maybe the orange block is moving at some other angle like this, maybe. Okay. You take the components of the velocity in the perpendicular direction of the contact. You take the components of the velocity in the perpendicular direction of the component. Let's say this velocity over here. Let's say this is some alpha. This is some V1. So this will be V1 cos alpha. Similarly, let's say this is beta. Let's say this is V2. Take the component of that velocity in this direction, which is V2 cos beta. Whatever components of velocities are there at the point of contact perpendicular to the surface, those components are equal always. So the components of velocities perpendicular to the surface to the contact surface are the same, are going to be the same. So in this case, you can just say V1's cos alpha component will be equal to V2's cos beta component. That's what it is. The point of contact you should see and take the velocities components perpendicular to the surface. What is the reasoning behind it? It kind of makes sense also. See guys, if you have a surface here and if you have another surface here, because they make contact with each other, so if this moves so much, it's obvious that this surface should also move by the exact same much to maintain contact, to maintain contact, to maintain contact. Both of them will have to move equally. If one moves more, then the contact is lost. If one moves less, then it is like piercing through the surface. So that is the reason why both of them should move by the same amount along the perpendicular direction. Is this clear? Okay. So let's do some question, and coming up on your screen, here it is. Let's say, for example, let's take this question only for now. Okay, this is like this. This is my surface over here, and there is a block like this, say. Okay, it's like this. So the yellow block is allowed to move along those guided lines up and down like this. And there is some angle theta over here. What's the relationship between the motion? That is the question. Let's try to do this question, my dear students. Okay. Now, because the yellow block is guided to go in this direction, in this direction, in this direction. So let's assume it has some velocity, let's say V1. Chumma. Let's assume it has V1. So at the point of contact, observe carefully, at the point of contact, that velocity will still be the same. It will be V1 and it is already perpendicular. So don't have to split anything as of now. Now look at the orange surface, the orange block. If you push this, maybe this will go like this. Okay, some V2 amount. So if you'll concentrate on the orange surface, that orange surface is now going like this with a velocity of V2. And that V2 velocity has an angle with the inclined surface, which is theta. So split the velocity into components. Only worry about the perpendicular component. How much will it be? This would be V2 cos. This will be obviously V2 sine theta. By our logic, these two should be equal. That's it. V1 will be equal to V2 sine theta. That is the answer. Very easy, very laddu solution once you understand the concept. Everyone, how many of you understood? Sai Priya, like I mentioned before, I would not be taking the NEET live acad classes as of now. Okay. So, Sudarshan, my dear, okay, check this out. Do you understand that this block can only go like this? It can't go anywhere else because of these two supporting objects. So, it can only go like this. So, if that particular yellow block can only go like this, if this has some velocity v1, even this has the same velocity v1. If you notice, this is the surface of contact, and what is the theory I give? Wherever the contact surface is there, take perpendicular components of those velocities. Already the surface of contact, this velocity is perpendicular, so I did not split only this velocity. If you look at the triangular part over here, if you look at that triangular part over here, Once you push this, this will move this way. So if this goes like this, every part on this, even this will go like this, even this will go like this, even this part which is in contact with this yellow part will also move like this with the same velocity. Correct? At that point of contact, split that velocity into two components. The perpendicular one is what is important because that should be equal to the other perpendicular velocity. So that's why these both are equal. Hence, this is the relationship. So if this is V1, this is V2, the relation is V1 is V2 sine theta. Got it? Now, everyone, Dhanarshi, Sai, Sudarshan, Dilip, Sanjay, cool. Shall we do one more question so that you guys get it? Shall we do one more question so that you guys get it, my dear students? Okay. Yes, let's do this. Let's take this problem again. Again, you have a wedge over here, and the wedge can move left or right on this horizontal surface like this. And now you have another wedge like this, which can only go up and down. Which can only go up and down. What is the relationship between these motions? This can go up and down. If this goes down, obviously think about it. If this comes down over here, this wedge will have to move over here. If this comes further down, the wedge will have to move further. So question is to find out the relationship between them. Okay, fair enough. All right. Focus, focus, Sudarshan. We are not doing spring problems now. Hello, Darshini. Welcome. No live classes, Sai Priya, on the NEET English channel for the portion as of now. Okay, because already we have kept so many portions recordings on that channel. Number one. Number two, DNA batch is also there. Number three, we were seeing most of the kids were anyways not watching it live. Okay, and they were not even uh, watching those classes there. Most of the physics students, chemistry students were attending JEE classes only. So there is a lot of effort which goes on. Plus, I'm more involved now in the Sigma batch and DNA batch. A lot of classes of mine are also there. So I am also not having that much time to again conduct so many classes. So that is the reason. Okay. Yeah. So better to be a part of the DNA batch. Anyways, on the DNA batch, I'm there. And Gopika ma'am, Baswa sir, Diksha ma'am, Pahul sir. Yeah, all of us are there. So better be a part of that. Yeah. Cool. Like this live classes, you want more classes? Okay. Yeah. Yeah, great. You will obviously get more classes like this. Here, this is the channel that you should be subscribed to. Can I take drop in my second year? Don't take a drop in your second year. Please continue, man. It's a big risk. Okay. Now let's see what do we do in this situation. Okay. Well, let's see what do we do. This block, yellow block, assume it goes down with some V1 velocity. So all the points on that block, all the points on that block, whatever are there, all the points on that block will come down with the same velocity. So that will be V1. But at the point of contact, check perpendicular component. Oh, so I need to drop a perpendicular over here. But what is that angle which it is making? What is the angle which it is making? Think about it, guys. Yeah. If this is theta, how much is this angle going to be? You have to use little bit of geometrical analysis over here. You will get the answer. I divide it into 8 parts and I use my 8-part method. See, this angle is theta. Why? This is theta. So this is also theta. So naturally, this is theta, this is theta, this is also theta. So this is theta, guys. So how much is that perpendicular velocity, guys? How much is that perpendicular velocity? V1 cos theta. Okay. So this part is very, very important. V1 cos theta. It's the perpendicular velocity to the surface. Now concentrate your attention on the wedge. Concentrate your attention on the wedge. Okay. Again, concentrate exactly that point which is in contact. every part of the wedge will be moving with some velocity v2. So even this part is moving with that same velocity v2. Every part of that wedge is moving with the same velocity. Now it is clear that this particular angle, the inclination is theta. So even this is theta. Okay, because this is theta, even this is theta. Take the component which is perpendicular to the contact surface. So V2 will be split into two components. How much will this component be? It will be V2 sine theta. This is the perpendicular component, V2 sine theta. As I said before, the perpendicular components should be equal. So on one side, we will have V2 sine theta, and on the other side, we will have V1 cos theta. So sine by cos is basically tan theta. So tan theta will be V1 divided by V2. That is the answer. So tan theta is V1 divided by V2. V2 is this guy's velocity. So that is the answer to this question. Everyone clear? Perfecto? Awesome, 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 awesome. Perfecto. Very good, very good. Amazing, amazing, amazing. Okay, perfect. Let's go. Sir, you also teach in Tamil? No, no, no. I don't teach in Tamil, man, here. Why V1 and V2 are not the same? Why should it be the same? Tell me that first. Like, what is the reason why it should be the same? I mean, just think about it. Because of this angle, when this comes down, this is now related that how much ever it moves and how much ever is the inclination. See, if this was not inclined so much, okay, if it was not inclined so much, so when it comes down, when this particular thing will come down, this will have to move differently versus when it is inclined by a lot and this comes down over here, then the amount by which this wedge will move will be different, because when it comes down, how much angle it is there, that will decide how much the lower wedge will move. So the angle matters over there, and because the angle matters, V1 and V2 can't be equal. Okay, everyone, guys, don't worry about spammers out here. The thing is that there will be a lot of spammers in the chats because English channel, JEE channel is doing well, and some competitors don't see their channels doing well because they don't have great teachers. So, you know, it is obvious that they have groups of spammers who they spam. They are not students, they are elder people. So let's not concentrate on those elder people who come in the chats and who are paid, they get salary. And I also know how things work. Okay, so they'll come at different places and spam this teacher, that thing. I don't care about such things. So don't worry. They are all spammers and they're not even kids. They're all uh, doing it as internship or freelancing. They're sitting in different cities. They get assignments. You have to spam in these channels today. Okay, don't worry. Gautam, whole lecture was on string constraints, most of it. I think you missed it. String constraint, 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 rod constraint, wedge constraint. Yeah, so many things we did. Okay, cool, cool, cool. Amazing. Now, in the previous lecture, there was a question related to this block moves by an acceleration. That question now can be solved by wedge constraint. So now I'll give you the hint, guys. So that question was something like this, where there is a wedge and there is a block over here, and this block has to fall down by g acceleration. So how much should this move by? I think now this is related to constraint. If this is coming down with g, how much should this go by? Exactly same problem. This is v1, this is v2. The relationship is tan theta. Now you get the answer, guys, directly. So tan of theta, assuming this is theta, will be v1 by v2. v1 is g over here and v2 is this acceleration over here, which is a. So a will be nothing but g by tan of theta, which is G cot theta. So if you move this wedge by G cot theta, this will come down with G acceleration. So this kind of question can also be solved. This was there in my previous lecture. Sai, the problem is even bio classes can't be conducted over there. Okay, because I think even Gopika ma'am is not free, and even Basav sir is not free, and that kind of uh, attendance is not there. So if attendance is not there on the channel, then so much of energy we have to put in. Already we have our DNA batch, other channel, so many things are there. So that is the reason even biology classes will not happen. Okay. Yes, there will be strategies. I will be meeting you all. We'll be telling you all the important tips. We'll be guiding you. We'll be providing free material. Whatever is there, that will continue on the Vedantu NEET English channel. But for the next couple of weeks at least, taking a live class when our batches are going on, we're not getting time because we have already lot of commitments. Okay, cool. So that was this answer, and I hope you enjoyed the class. Please like the video and stay subscribed if you want more classes, because at the end of the day, your attendance matters. Your